Hello, today we're looking at sex linkages. And what these are, sex linked are any genes present on one of the sex chromosomes, so either X or Y. And these are not fully homologous, so they are slightly different. And as you can see in this diagram here that I've done of the X and the Y chromosomes, we can see that the Y chromosome is much smaller than the X chromosome. So we can see that a small part of the X chromosome matches a small part of the other, so that these chromosomes can pair up before meiosis, so these are the same. But there are some alleles here that aren't present on the Y chromosome. So, when a male would inherit a characteristic, for example, one of these, that is what is expressed. So, if a female has one abnormal allele on one of her X chromosomes, so here if this was abnormal, she might have a functioning allele on the same gene on her other X chromosome. So her other X chromosome could have a functioning one of these alleles, even though this one here is abnormal. But if a male inherits from his mother an X chromosome with an abnormal allele for a particular gene, he will suffer from a genetic disorder, because he won't have another functioning allele for that gene on the Y chromosome. So males are said to be hemizygous for X-linked genes, so they can't be heterozygous or homozygous for X-linked genes. They just are what is inherited from their mother. An example of this is haemophilia, haemophilia A. And that is just a disease where you're not able to clot your blood fast enough. But one of the genes on the non-homologous region of the X chromosome codes for a blood clotting protein, and this can be like mutated. So a female with one abnormal allele and one functioning allele, so she would produce enough of the factor VIII, which is what's needed to clot the blood, to clot her blood normally. So a female wouldn't suffer from this because they'd have two of the chromosomes. However, if a male was to inherit the abnormal allele, they wouldn't have a functioning allele to fall back on, so they would just have this one. So they wouldn't be able to produce the factor VIII needed to clot the blood. So I will put this in a Punnett square. So if we have the mother would be females are just cannot actually carry the disease because they would have, if they had two abnormal, they probably wouldn't, it just wouldn't survive reproduction. So they can be symptomless carriers though. So they've got one faulty allele and one normally functioning one. And if we represent that by capital H and lowercase h. And then there's going to be one if there was a normal male. They would be X capital H, which is the dominant trait for the normal functioning. And then sorry, that's wrong. Should it be XH and then Y, because they don't have another X chromosome. And then we've put these into the gametes. We would have, here we could have two possible ones. We could have XH or XH lowercase. We could have XH or Y. And if we put that into a Punnett square, the male goes here, X capital H or Y, and then we've got X capital H or X lowercase h. So it could have XH, XH. So this could be a symptomless carrier female. We could have a normal male. But we could have here a male with haemophilia. Or here this is a normal female. So we can see that we can't have a female with the disease, but we can have a male with the disease. And that's really all there is for sex linkage. There are other examples in cats, but I'm not going to go into that here. Thank you for watching.